All right, this is lesson 78 for geometry, and it's on rotations. And the first definition, it says a rotation is an isometry, and that means a translation that does not change its shape or size, or shape. So if I have this triangle and I'm rotating it with rotation, its size and shape are not going to change in the rotating of it. And we will be starting out pivoting on the coordinate plane around the origin. So on the coordinate plane we have the x and y axis, and the origin is where they intersect at 0, 0. Those are the coordinates for it. And so if this were it, and I labeled it T, then I would rotate each degree around the origin, and it would maintain, and my illustration does not indicate that, but it would maintain the same distance from the origin no matter where the rotation was. And so it would keep that distance equal no matter where it was. So with that in mind, if I were to have x, y as my coordinates for 0, 0, then I'm sorry, not for 0, 0, but for some point on my triangle. If I'm following, if I call this point right here, if I'm going to follow this point all the way around each time I rotate it, and it's xy right now, if I do a 90 degrees, it's going to become negative yx after 90 degrees. If I were to rotate it 180 degrees, my xy, whatever that one point of that triangle is, one corner, then it would become negative x, negative y. And then if I were to do it, rotate it 270 degrees, my point of the triangle that I'm following, x, y, it would become y, negative x. And so as an example of this, let's say this point right here is 4, 3. So I'm going to do 4, 3, 4, 3, 4, 3, 3 different ways. I'm going to do 90 degrees, 180 degrees, and 270 degrees. So it's just simple. If 4, 3 would become negative, instead of x, y, it would be negative yx. So the y, which is 3, would become in the front with a negative. So it would be negative 3, 4. And if it was 4, 3, and it went 180 degrees, it would become, they would both become negative. So negative 4, negative 3. And then if it was 270 degrees, xy would become y, negative x. So y would be first again. That'd be 3, negative 4. So it's very simple. This chart is in your book right here on page 511. And you will just, if they ask you that, you can just simply refer to that, and you don't have to do any math or any drawings. You just look at this pattern, and it's consistent no matter what the coordinates are that they're talking to you about. So that is that if you're pivoting around the origin. Now, if you're not pivoting around the origin and you're pivoting around some other point on the coordinate plane, let's say right here is the point you're pivoting around, and here's my triangle, and I'm going to pivot around 90 degrees, and it's going to become like that, then this point right here becomes our T. That means the point where you're pivoting around. So in this case, T was the origin. In this case, we're going to refer to it as AB. We call it AB. And so in your problems, they'll say AB is this. And so whatever that AB is, that's where they're doing their pivoting around. That's their center point. And there's a formula that you would follow. So if I am pivoting around 90 degrees from here, and I notice this is 1, 2 spots away from there, and then it stays 1, 2 spots around. So it stays 2 units away no matter where I'm going. Then I have a formula. I would say 2, and then here's my A and B minus x, 2 times A minus x, and 2 times B minus y. And that's the formula you would use. And so let's use that as an example. So if here is my AB, that's where I'm pivoting around, and I'm right here right now, and I'm going to pivot over to here. So let's say I start, my AB is 7, 8, all right? And I'm going from here to here. And I'm sorry, not 7, 8, it's negative 2, 3. And so I'm going from here to here. So my 7, 8 is where I'm starting. And I'm going to move it, I'm going to use this formula, 2a minus x for the first number, 2b minus y for the second number. So I just plug in my a and b everywhere where there was an a and a b. So I'd be 2 times negative 2 minus, then here's my rotation point, 7 and 8. And you just plug those numbers in and you do the math. So 2 times negative 2 is negative 4, negative 4, negative 7 is 11. And then, negative 11. And then 2 times 3 is 6, minus 8 is negative 2. So that would be where I ended up. And what you're trying to figure out is, if I started at 7, 8, where will I end up if this is negative 2, 3? So that is how you do that. And there's an example of that in the book. It's not hard. You just use the formula and it will all work out. So for your homework for this, they're going to have you do 2 different ones. You're going to do it around the origin. You're going to do, let me take a look. So if you have, okay, first they're going to have you draw a triangle. They give you the coordinates to draw the 3 points. And then they're going to have you rotate it 90 degrees around the origin and then redraw a new one. And so when I draw a triangle, the first one is called the pre-image. We call that ABC. The new one is called the image, and it would be A prime, B prime, C prime. And so that's what they want you to draw. In the second problem, you are going to, you're given the coordinates again, and you're gonna rotate it 180 degrees around a different point. So you would use this formula again and plug that in and do the math. You don't have to draw it this time. You just give the new coordinates. And you're just doing A and B in the lesson practice for lesson 78.